Alright, physics kiddos. We've been introducing electricity in our previous day of notes, so now we're going to start talking about some of its most important characteristics, which are mathematically related to one another in Ohm's law. So this is 6.2 Ohm's law. There's three critical characteristics. The first is the voltage. Voltage is a form of potential energy. Basically, if you have a charged particle and it's sitting in an electrical field, it wants to move towards one pole or the other. It's being attracted to either the positive or the negatively charged pole. How strongly that desired move is, the amount of stored up energy, depends on a couple different things. How charged the particle is, what the field strength is, and the distance between the poles and the particle. What's keeping it from moving? That depends. There's a type of friction that'll stop things from moving, which we're going to get to in a minute. But voltage is just storing up that ability to move. It's kind of like a gravitational potential energy in that sense. The unit is going to be volts, which is easy to remember, where 1 volt of energy is the equivalent of 1 joule of stored up potential energy per coulomb of charge. And the symbol is given as delta V, because this is another case where there's not really there's no zero voltage. Everything has some small amounts of background charge, and so we're looking at change in voltage. As the electrical charges are moving through the media, they develop current. This isn't the same as the electrons moving, mostly because the electrons have positive the electrons have negative charges and the current is looking at the positive charges. My understanding is they were sort of guessing when they slapped the direction on it, and they had a 50-50 chance of being right, and they were just wrong. And so it's considered to be the opposite direction, which is silly. But the current is given the letter I in our sorry, my dog is fussing. Our current's given us a letter I in our equations, but the unit is in amperes or amps. Sometimes you see it with a little circle at the top, but I couldn't find that symbol, so we're just going to leave it the way it is. Where 1 amp is equivalent to 1 coulomb of charge moving in 1 second. The speed of the charge is near light speed. We're not literally talking about electrons moving around, because if we had to trace the path of a single electron, it doesn't go in a straight line. It's kind of all zigzaggy and all over the place. The electron speed is known as the drift speed, because they really don't have a straight linear motion from one end of the wire to the other. It's a lot more like dominoes, where you push electrons into one end and different electrons pop out the far end. If we try to push a single electron all the way through, it would take ages. Not because electrons are slow, but because they're small. Okay, and then there's resistance, which is opposition to that motion. It's kind of like friction. It's slowing down the motion of the electrons and the motion of the charge. The unit is ohms, which is given the Greek letter omega, which is that cool sort of double Q thing. I don't even know how to describe that. Where 1 omega is equivalent to 1 volt per amp of charge. Sorry, 1 volt per amp. So, yeah, it'd be complicated. Joule per second? Because volts are divided by, anyway. So, there's a mathematical relationship between these three things. Ohm's law, where the voltage is equivalent to the current multiplied by the resistance. So let me just push this all the way down. It's a really simple mathematical formula. We're going to be doing some equations with this, but I didn't actually work out any examples because I figured it was just that easy. The only thing to keep an eye on is your units, but other than that, the math involved here is really easy. If you have more interest in Ohm's law, there's lots of good videos on YouTube for that as well. But I'm going to go ahead and end mine here because that's the end of the notes. It's a short day. But anyway, take it easy, and I'll talk to you guys again soon.